Okay, so this is a run through of the experiment book to prepare a solution of sodium thiosulfate and standardize it by titration against a solution of iodine. So the first thing I want to bring your attention to is the equation up here. So this is what's happening in the conical flask. So we have KMnO4, our potassium iodide, and our sulfuric acid that went in. So that should fully reduce to Mn with an oxidation number of +2. If it doesn't, a brown precipitate will be formed within the conical flask. 5 moles of iodine in terms of ratio should be produced with some water. Taking that 5 moles of iodine in terms of the ratio, that should then, if that was a 5, that would be 10 moles of the sodium thiosulfate, which would produce then and free the iodine ion. So we need to know that ratio and how to take this 5 iodine up here in the conical flask down into this reaction, which is the actual titration reaction, iodine against the sodium thiosulfate. So if we flick and go to our first calculation section, the amount of mass of the sodium thiosulfate measured was 6.25 grams in the lab. You might not have got exactly that, but that does not matter because what we're working out here is the actual concentration of that. So write down exactly what you got. The volume of the potassium permanganate was 25 centimeters cubed, as per usual from our pipette. The molarity then, depending on your previous experiments, could be 0.02, 0.018, 0.014, whatever you got, but you can put it in here. The average titer should be around 23-ish. So it depends on the accuracy and the concentrations of both your sodium thiosulfate, your iodine, and sulfuric acid, and the potassium permanganate. So to find the average, you go to the ones that are in 0.1 of a difference, find the average, add them, divide by 2, and you should get your average titer. Okay, so bring it over here. Now there's our equations once again. So it says it here, 2 moles of KMnO4 gives 5 moles of iodine. And if we multiply that by 5 all the way across, you should get 10 moles of the sodium thiosulfate. So I'll just show you here what we're doing. We're taking that 5 and I need to put a 5 here. So I basically need to multiply this whole thing by 5. That would then turn into a 10. That would turn into a 5. And that would turn into a 10. Okay, so you're taking the exact same ratio here and here. Moving down then, we're just going to fill this in with our measurements. 25 of the potassium permanganate, its molarity, and the number beside the potassium permanganate is 2 up here. Okay, so you probably won't get this handy little diagram within an exam question. You'll only get these two, so you'll need to go from here to here. So our oxidizing agent has a 2. Moving along, multiplying this line by 5, we can see that our reducing agent has a 10 beside it. So that's where the 2 and the 10 comes. This is just your average titer. Our last page is where we work out the actual molarity of our sodium thiosulfate. So we can fill in our formula as per usual. Fill in all the oxidizing agents calculations, 0.02, 25, 2. That might be different. Molarity is a reducing agent, your average titer, that could be different for you, and the 10. Putting that in, I got around 0.1089 moles per litre. If I want to find out the grams per litre, you multiply it by the molecular mass. And I got 30.94 grams per litre. That's all that you were asked to do. And your conclusion is just taking that calculation and write it into an English format So I said it took 22.95 centimeters cubed of 0.1089 moles per litre sodium thiosulfate to fully reduce 25 centimeters cubed of KMnO4, and you can write in your molarity there. Okay, and that's it apart from the questions.